Now this is the first example, non-homogeneous linear equations in two variables. X plus 7y is equal to 10, 4x plus 28y is equal to 40. You know that if the equation condition is a1 by a2 is equal to b1 by b2 is equal to c1 by c2, it has infinite solution. I had discussed in the last video. So by matrix rule, coefficient matrix is this 1, 4, 7, 28. Variable matrix, and this is the constant matrix. Determinant of A is equal to 0. Adjoint of A is this. Adjoint of A into B I have to find, and I find that it is null matrix. Therefore, it is consistent and it has infinitely many solutions. I take y as k. Y as k. So x is equal to 10 minus 7k. This is the answer. And remember, by looking at the expression, if this is the condition, you will get infinite solution. Now the second example, here you will find a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. That means it has to be inconsistent. By matrix rule, this is how we are going to explain. It's a coefficient matrix, the variable matrix, and the constant matrix. Determinant of A is equal to 0. Adjoint of A into B is not a null matrix. Therefore, it is inconsistent. This is true. We had discussed this here at the beginning itself. So I take another example, a non-homogeneous linear equations in three variables. Now I find the coefficient matrix 1, 2, 3, the first column, minus 3, minus 6, minus 9 in the second column, 5, 10 and 15 in the third column. Now you will find one thing here. If I multiply the elements of first row with 2, I get the second row. 1 into 2 minus 3 into 2, 5 into 2. And if I multiply the elements of first row with the elements of third row, if I'll multiply the elements of first row with 3 ones are 3 into minus 3 minus 9, 3 into 5, 15. So this is the condition. So its determinant has to be 0. But you won't find the same thing happening here. 4 into 2 is 8, not 11. 4 into 3 is 12. So just by looking at this, you will get an idea that it cannot be consistent. It has no solution, but still by matrix rule we have to prove that. So determinant of A is 0. By property only you can write. No need to simplify. Adjoint of A 0, all null matrix. Adjoint of A into B, null matrix. Now amongst the three equations that I have to select any two. And let Z be equal to K. The two equations in two variables I get now. Coefficient matrix, the variable matrix, and the constant matrix in terms of K. 4 minus 5K and 11 minus 10K. Determinant of A minus 6 plus 6, 0. Adjoint of A, interchange, minus 6 will go here and sign change here. By property also you can write this as 0. Adjoint of A into B is this. It is not a null matrix, that means it is inconsistent and it has no solution. So three equations are given, non-homogeneous equations in three variables. First step is to find the coefficient matrix, coefficient of x, coefficient of y, coefficient of z, the variable matrix and the constant matrix. First we find determinant of A, and here we find is equal to 0. Therefore we have to further find adjoint of A into B. Adjoint of A, you know how to find? Adjoint of A into B is a null matrix. Now we have two options. If it is consistent, it will have infinitely many solutions. If inconsistent, no solution. We select any two equations amongst the three. There are three equations given here, we will select any two. Let Z is equal to K. So now we get two variable equation, coefficient of x, coefficient of y, this is the coefficient matrix, the variable matrix and the constant matrix in terms of k. The determinant of A is equal to 3. It is not equal to 0. Therefore, we have to find A inverse because X is A inverse into B. And then we get X as 5 by 3 and Y is 3k minus 4 by 3. Now, and Z is equal to K. Using these values, we have to find out whether these values in terms of K satisfies the third equation or not. So, using these two equations, I found the value of X, Y, Z in terms of K. And then those values I have to substitute in this and check whether they satisfy or not. So, here I have taken the third equation. X is 5 by 3, Y is 3k minus 4 by 3, Z is K. After simplifying, I find LHS is equal to RHS 1. So, it is consistent, infinitely many solutions it has. Depending on K, which is the real number, any real number, this is the final solution.